Hello, my name is Valerie Stolf, and I will be reporting my results and observations for Physics 2212, Lab 1, Charge Tape. The purpose of this lab was to transfer electrons between objects to create a piece of clear tape with an electric charge. From here, I observed the interactions of the charged tapes with various household objects in order to ultimately determine the amount of excess or deficiency of electron charge. My results showed that the charge of a piece of tape is equal to the square root of the electric force times the square of the distance between two charged tapes, all divided by K, Coulomb's constant. Interactions between the charged tapes and other objects revealed that the pieces of tape are positively charged. The physics principles used to come to the conclusions were the momentum principle, Newton's third law, and Coulomb's law. In order to determine the sign of the charged tapes, I observed and documented the interactions between the tape and my hand, a wooden table, a negatively charged plastic pen, and another charged tape. The U-tape showed a moderate attraction to my hand and the table because these objects should be neutral and show some attraction. The plastic pen and the U-tape showed a strong attraction. Because we know that the plastic pen has a negative charge, it was then found that the U-tape must have a positive charge. Because two identically prepared U-tapes repelled each other, it was clear that they were both positively charged. To determine the actual magnitude of the charged tapes, the momentum principle and Newton's third law were used to equate the gravitational and electric forces so that the charge could be solved for. In order to do this, it was necessary to assume that the two charged tapes would have equal charges of equal magnitude. In the two-tape system, all momentum is conserved between the two equal and opposite forces acting on the floating tape. This is seen in lines 14 and 15 of the GlowScript code. To solve for the tape charge Q, the electric force was set equal to the magnitude of the known gravitational force and then used to solve for Q. Given that the tape length was 0.254 meters with a mass of 2.54 times 10 to the negative fourth kilograms and floated at a distance of 0.048 meters above the tape, it was calculated that the value of Q is 2.53 times 10 to the negative ninth coulombs. After finding the magnitude of the electric charge of the tape, I was able to calculate how many electrons the tape was deficient by to give it its positive charge, resulting in a deficiency of 1.58 times 10 to the 11th electrons. Then, to find the electron-to-atom ratio, the area of the tape and the area of an atom were used to find that floating charge tape contained about 4.8 times 10 to the 17th atoms, giving an electron-to-atom ratio of 3.3 times 10 to the negative 8 to 1. These calculations can be viewed in lines 27 and 28 of the GlowScript code. The GlowScript model is included to visualize this idea that two pieces of charged tape, one held in place, can cause the other to remain in a fixed position, assuming no other forces are acting on the system and that the electric force is constant. This is seen by the fact that the blue electric force arrow and the red gravitational force arrow are of the same magnitude, but in opposite directions, allowing the net force of the system to be zero and the tape to float. To summarize all of these results, I found that the U-tapes were positively charged after observing the interaction between a tape and a negatively charged plastic pen. Using Newton's third law and the momentum principle, I was able to assume no other forces other than gravity and the electric force were acting on the tapes in order to find the approximate magnitude of its charge. This calculation was confirmed by the calculated electron deficiency of the U-tapes. These results, however, are not completely accurate. Deviations may have occurred from error in measuring the floating distance between the two tapes, as well as assuming that no other forces other than the electric force and gravity are at play. Also, slight differences in amount of skin contact of the two tapes would affect the magnitude of the charge. Lastly, these results would stand even if electrons were positive particles and protons were the negative particles. This is because the tapes would still have the same magnitude of charge and would still be positive because of the fact that electrons are the transferred particles. In this case, however, there would be an excess of electrons instead of a deficiency. Also, throughout this experiment, it was important to minimize contact of the tapes with other objects so that polarization effects would be minimized. If a significant amount of contact were made with the tapes and other objects, then positive charges would move farther from the tape and closer to the objects in contact, and this would affect how the two tapes would interact with each other, and the expected results may not be observed. Thank you for watching.